here, we're going to have to subtract that from 180. So you'll always just take this answer and subtract it from 180 to get the other possible answer. And that'll be every time you're doing one of these. So I'll put or here below this, b equals 180 minus 49.46 degrees, which is what? 131.54. 130. See, I'm not doing the arithmetic, sorry. I leave that to you. 130.54? Okay. So these are our two possible answers, right? These are our two possible answers. Let's do a quick mental check here to see if they would both work or not. Let's see, if I use 49.46 here, 49.46, are my sides going to correspond properly? This side is smaller than this side, right? And this angle 35 would be smaller than the 49.46, so that would be good. And of course, 35 and 49 don't add up to be 180, so I'd be okay. Now let's try the 130. If you put 130 in here, is the biggest side match up with the bigger angle? Yes. Okay, do they add up to be more than 180? No. So both of these are possible, which means I need to create another table with other information. We're going to just basically have to do two problems at one time. Well, two problems separately. Yeah, you said it. But this is as bad as it gets, okay? It doesn't get any worse than this. This is the two-case scenario is the worst case, which is the one you'll see on your test, right? You still want a bunch of these, though, right? That hasn't changed? I have not, no. Okay, so now I have two triangles possible. And one of them is 49.46. And the other one is 130.54 degrees. So now you do both of those. Why don't you take the next 5 minutes to see if you can't solve. These are independent problems, right? Do this, finish it, okay, and then come over here and do this one separately, finish it. If you don't have a calculator, you can use your phone. And if you don't know how to use ArcSine on your phone, well, then that's just a shame. That's just shame on you. Turn your phone sideways, and most of them will turn into scientific calculators. You want to borrow mine? Are you okay? You got it? Okay. Bless you. Who's got it already? A little more time. While you're doing that, I'm going to set up the next problem.
What is the biggest?
Okay, are y'all finished? Okay, what did y'all get for the first triangle we did where the angle was like 46 something? What was capital C and little c? Was it capital C and little c we were going after? We already did capital C? No, okay, what was capital C? 95.54, and then what did little c become? 10.41? Okay, and then on the other one, 0.46, 2.61. Okay, that's what you should have got for the two different triangles. All right? Okay, let's take a look at this problem here. This should look familiar. That's a building. If you can't tell, again, you need to go get checked. This is actually a really good building. You've got these people. You're able to measure an angle from the ground up to the corner of the building. You can measure that angle twice, and you can measure the distance between here and here. Let's just say that this is 250 feet. I'm just making this up, okay? How tall is the building? Does this look familiar? Like we did something like this in the beginning of the semester. So how tall is this building? That's all the information that you're given. So yeah, let's label some stuff here. What do you want me to do? Big A's and big B's. All right, why don't we label the height of the building H? How about that? I'll do that. So we're supposed to find H. So what are some ideas here? How we can do this?
We've got two triangles there.
Okay.
And one of the sides to the triangle is going to be there's a big triangle that has a side.
So we have.
Yeah, you have sides that are in common.
I see. When you say two triangles, I see this one,
Yep, there's a triangle that has
and then I see this one.
right, and they both have.
But then I could have also said, like that one. Like this would be one big right triangle,
Right.
and then this one would be a small right triangle, which is the way we attacked it before, like previously.
I say we find the two angles on top.
You can find which angles? These angles up here. All right, y'all want to do some angle work? We can try some angle work. Do you know this angle right here? Look at this right here. So this is 90 and this is 43, so that's 133. So this has to be 47 degrees right there. Yeah, we could do that. I'm okay with that. Anything else?
You can get the one across from 43 too and do the other thing.
Okay, so what is this angle right here?
137.
That's 137. I agree. I'm not disagreeing with that. You get that that's 137? Because 43 plus 137 gives you the 180, which is all the way straight line. That makes sense? And then could you give me this angle right here? Just this one right here? Could you? What would that be? 10? Is it 10?
Yep.
Okay, so this is 10 degrees. Why is that 10 degrees? Let's see. Because 90 and 33 would be 123, but then this whole angle would have to be then 57. But this is already 47, so that would have to be 10. Yeah, is that the way you got that? Okay, so yeah, I mean, we could do all that, but all right. Now what? Let me ask you this. What if I had this side right here? If I had that side, would that be good? Let's see why that would be good. Let's call that, just for the sake of calling it something, let's call that B. Okay? Let's call that B. Let's say we had B. All right? Let's just say we had it. Then do you agree with this statement? Sine of 43 is H over B. 43 degrees, right triangle here, right? Sine is opposite over hypotenuse. And if I know what B is, then I know what H is, wouldn't I? Yeah? So if I had B, this would be, I would be there, wouldn't I? If I had B, I'd be there. You cannot, this comedy is next level stuff, okay? If we had B. Can we get B? Well, B is part of this triangle, isn't it? So let me just kind of draw that triangle. It's a terrible triangle, but that's going to work. B's here. And then this is 33. That's the angle that goes with that B. Should we have called it little b? I think, let's call it little b. That's why we write in pencil. Little b. Little b. Okay. All right, so that, I have the angle and then its corresponding side, right? I've got those matched up. Y'all see them right here? And then I have this side right here, 250, I know that side. And I also know 137 here. Oh, and did y'all get the 10 from just doing these two? Oh, okay, you could do that too. 10 degrees. Yeah, that's pretty easy that way. So y'all see this triangle? I think we should be able to get B from this. Let's see. Let's try and label some things. We don't have to do all the labeling, but I'm just trying to help out here. This is capital B. Let's call this side this angle, let's call it C, and this side little c. Can't tell my little c from my big C. Little c, capital C. Do y'all see that? So can you get little b? Yes. What am I going to use to get little b? Yep. So what is the equation I'm going to use? The b, little b over sine b equals little c over sine c. So from this, I have little b over sine of what? Big B, which is 33 degrees, must equal little c, which is 250 over sine of 10 degrees. Anyone? Little b yet?
Yeah.
What do you got?
784.11.
784.11. Anyone else? Yep. Okay. So I used this kind of outside triangle, used this side and my knowledge of the angles to be able to produce that hypotenuse. Once I produce that hypotenuse, I can use just basic right triangle trigonometry. Sine is opposite over hypotenuse to get my h. So I'm ready to go get h now, right? You all with me? Okay. So now going back up to this, I'm going to turn this into b sine of 43 equals h, and b turned out to be 784.11 sine of 43 degrees. Is this a realistic building or not? Let's see. I kind of made up this problem, so how tall is it? 534? 0.76 feet is h, approximately. I think you would agree that it's not, yeah, I won't take claim for that. I don't know, how tall is each story of a building? I mean, at least 10 feet. So this is like, these are windows, obviously. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's like an 11-story building. There's a really tall people live in this building or whatever, but that's the height of the building, okay? So, that's right. So that still took some work, okay? But if you compare how you do this without law of sines compared to how you do it with, this is much easier than just doing right triangle stuff. You could do this with just right triangle trigonometry, but it's just much more difficult. I believe what we had to do is we had to like call this side like x, and then we like 250 plus x is one side, and then we use a big triangle. It becomes really a mess. Wasn't it a bonus problem or something? Or yeah. Okay. All right, 217. Let's at least get started with law of cosines. Sorry, I'm just thinking about something here. .3 Law of Cosines. So the proof for law of sines was easy to follow? Yeah, it was relatively easy. All right, the proof of law of sines, do we care to see the proof of law of sines? like geometric proof? Yes or no? 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 We have one no? So, no? Okay. So you're just going to take it on faith. Now let's look at an example where we would not be able to use law of sines. We talked about this earlier. Someone brought it up. Who brought it up? Who brought this up? Like if we had certain combination of things. So what if we had like, A was 5, B was like 2, and then C was like 30 degrees. Like, can we do law of sines here? Can you? Law of sines? You can't. Because if you're going to try and find capital A, right, you're going to use little a, and then you need capital B and little b, or capital C and little c. You need one of these sets, don't you? And you don't have a complete set with the other variables. So there's no way to get this with law of sines. But that's where law of cosines comes in. Is law of cosines can deal with this. So here's what law of cosines says. Here's the formula for it. It says that, let's see which version I'm going to give you. Little c squared equals little a squared plus little b squared minus 2 times a times b times cosine of capital C. That's the formula. That's the formula for law of cosines. What?
But it's always the same.
Or, so look at it this way. If you wanted to solve for little c, here's a formula for it. Yeah, let's analyze this formula. If I wanted little c, what do I need to find little c? I need little a, I need little b, I need little a and little b. I need those two, right? And then I need capital C. This formula would then produce little c. Got it? So the way you can look at it in a triangle, in terms of a triangle, if we go back to the original drawing, and I forget how I did these, but I'll just do this. If you look at this little drawing here, in the law of cosines, which parts would I need to know? If I wanted to find C, right? If this was what I wanted to know, little c, I would need to have little a, little b, and then the angle between them. So if you have two sides of a triangle and the angle between them, you should be able to solve for the side opposite of that angle. Yes?
So it could be like little b, little c, and a.
Yeah, so that means that this formula could be changed up. You could replace this with b squared. I don't know if this is what you were saying.
Yeah.
Okay, so this could be b squared equals a squared plus c squared minus 2ac cosine b. And that would work also. That would be like if we wanted to know little b, we would need to know little c and little a and capital B. That's the version of that formula. There's a third. Or if I wanted to know little a squared, it's going to be b squared plus c squared minus 2bc cosine capital A. So I've got those obviously memorized, but I have more memorized the pattern than I actually do the letters. Like I know it's like if I want to know what one of the sides is squared, it's one of the other sides squared plus the other one squared minus 2 times the product of those two sides cosine of the angle that corresponds with it. I mean, however you want to memorize it, or it's on your formula sheet, right? So I should be able to use those formulas. I should be able to get little c this way, right? So that works. And we'll do an example. However, I would like for us to do this instead. We'll get to this. Sometimes we want to solve for capital C, capital B, or capital A, and we want to use these formulas. So watch what I'm going to do. I'm only going to do it to one of these formulas. Let me go back to the original one that I gave you. And what I would like to do is solve this equation to get this by itself. So if I wanted to get that by itself, what would I do first? Move these two things over, right? So wouldn't this become c squared minus a squared minus b squared equals negative 2ab cosine of capital C, right? That's what that would become. Now let's divide both sides by negative 2ab. So if I take this c squared minus a squared minus b squared and divide that by negative 2ab, I would have my cosine C here, wouldn't I? Now, most books will not leave it like that. What they're going to do is they're going to take this negative and they're going to pull it out front, and then they're going to push it to the top instead. And what that does is that becomes a plus, this becomes a minus, a plus, and a plus. Y'all see that? And so the formula that you will see in the back of most books is cosine of capital C equals a squared plus b squared minus c squared over 2ab. So if you want to know what little c is, use this. If you want to know what capital C is, you can use this. What do you need to know in order to know capital C? What do you need to know? Little a, little b, little c. Right? So if somebody gives you all three sides of a triangle and no information about angles, you can recover the angles with this formula. We'll do it. But that's, and of course, there are three different versions of this, right? Cosine of capital A would be b squared plus c squared, right? All right. Let's do this example. I do have good news, though. I do have good news. The great thing about the law of cosines is this. If you ever have to solve for an angle and do arc cosine on both sides, what's the domain restriction for the arc cosine? Where does arc cosine force you to look? 0 to pi, right? So the arc cosine function is going to give you angles between 0 and pi, which means you don't ever have to worry about two possible scenarios, because it's going to get them all, like it's going to cover it all. Where with the arc sine, we look just over here and we miss some answers. So that is good news about the arc cosine, or about the law of cosines, is that it doesn't give you that double two scenarios to look at. All right, let's do this. I want to know little c. So I'm going to just write down the formula. C squared equals a squared plus b squared minus 2 times a times b times cosine of c. And then I just replace things. Cosine squared is 5 squared plus 2 squared minus 2 times 5 times 2 times cosine of 30 degrees. So c squared is 25 plus 4 minus 20 cosine 30. So I'm just making sure I do order of operations correctly here. You know, I can multiply all these together, right? I square those, but I can't combine all those numbers. I can only combine these two. So c squared is 29 minus 20 cosine 30. Now cosine of 30 is like root 2 over 2, and you can, but we want a decimal, all right, because we're looking for the length of a side here. So does anybody have what the right side of this turns out to be before you take the square root on both sides, because you have to take square root on both sides. So what is 29 minus 20 times cosine 30? 11.67, okay. So 11.67. And final step, square root both sides. And remember that when you take a square root, you have to do plus or minus, don't you? However, C is the length of a side of a triangle. So it's going to be just the positive answer here. But I'm just being technically correct here. When you square root something on both sides, you're supposed to consider both cases. So C is 3.42-ish, yeah? 3.42? 3.42. What now? What's that? Thought I heard it. Go back to the law of sines now. Because now you have a pair to work with. You have a pair to work with. If you want to find capital B, do sine of capital B over little b equals sine of capital C over little c. That will get you your B. Once you know B, you know A because they have to add up to be 180. Then you can do your law of sines and get, oh wait, we already have that one, never mind. Understand? So we just need the law of cosines just to get that first missing piece, and then we just resort back to law of sines. So you think you take that the rest of the way? Yes.
So we only use law of cosines if there's only one big letter given and two little letters?
Well,
If you don't have a capital.
yeah, it depends on how you say that.
Oh,
The fact that the reason I use it is because the angle I had, I didn't have a side, right, going with it, and the other two sides I had. This is why I don't like getting into angle side, side, all that. Although I do like angle side, side. Is it angle side, side?
so if you're
It's humor, man. I'm telling you, next level stuff.
So
What?
if the big letter doesn't have a pair with the little, then you have to use law of cosines to find it.
If you're, say it again?
If the capital letter doesn't have a pair with the little letter, then you have to use law of cosines to find it.
Not if I would have had like that. That I wouldn't have needed law of cosines for.
No, I mean like the way you had it before,
Yes?
how 30 didn't have anything to go with it in C.
Yep.
That is when we do law of cosines.
Well, 30 doesn't have anything go with it right here, right?
Right.
I would not use law of cosines here. Why?
Because you have to.
Because I have this angle, right? And now I have two angles, right? Which means I have this one. There I have a pair. You see?
Yeah.
So that's why I don't want to give you all something where it's like, if you see this, do this, do that. I don't want you to think about it like that. Just, I don't know. Is that too abstract, do you think, to look at the scenario and try and analyze it each case?
I see it. If you can't, yeah, I
Yeah.
see it.
What we're looking for with law of sines is you've got to have at least one of these pairs, okay? Somewhere you've got to have a pair to use law of sines.
And if you don't, then you use law of cosines.
If you don't, use law of cosines. However, now let's look at this. I wanted to do one more example. And that would be something like this. Where you're not given any angles, and all you have are all the sides of a triangle. Right? And the question is, can we actually recover the angles of this triangle? Well, I gave you a formula just a second ago, and I said sometimes we solve that law of cosines for what cosine of capital C was equal to a squared plus b squared minus little c squared over 2ab. Remember that? I had that up on the board a second ago. If I'm not mistaken, I think that your formula sheet only has like one version of this. I don't think it has this version. Does anyone have it right there? The formula sheets? You should be familiar with what it has and what it doesn't have. Yep, it does. It gives you the three versions of the law of cosines, but it does not solve them this way. It doesn't do that for you. At least the formula sheets that I provide for you that you use, and those are the ones that are used in calculus. So, you kind of want to get used to what you're going to have and not have. So I'm gonna use this though, and so I have cosine of c equals a squared plus b squared minus c squared all over 2 times a times b, and this is what cosine of c is. So I get like negative 0.6875. Anyone else get that? Yeah. And at this point, you do arc cosine. So if I do arc cosine of cosine c, it'll kill it off. Arc cosine of negative 0.6875. So c will be 133.43 degrees. Yes? Once I have this, I can go back to law of sines, or if I really like that formula, I could just use the formula with this being b, which would make this a and c, and that b, and then this a and c. So you could, whichever way you want. Does that make sense to you? Like how you could just reuse that formula but change it up? We are about to go, but I want to just re-stress to you why it is that we don't have to worry about the double scenario here again. If I say cosine of an angle is negative 6.87, cosine is which coordinate? X coordinate. This is saying your x coordinate is negative 0.68. X coordinate negative 0.68 is probably about right there, right? Would you agree that's about negative 0.68? The other possible answer is down here. Why can't that be? That angle is bigger than 180. And this is an angle in a triangle, so it can't possibly be bigger than 180. So there is only one answer possible. Even though cosine might eliminate a possible solution, that solution lives outside of what's possible for a triangle. Okay. We are done with this. Suggest that you do the homework for 9-2, Law of Sines. And we're cruising along. Our test is on Thursday, right?
What section are you going to, is that for the past section?
For what?
For that quiz that's on Thursday?
The test on Thursday?
Or the quiz?
What about it?
What sections are you doing?
I need to go back
The ones from the, what we did like last week?
from the last test up through where we stop on Thursday is what the test will cover. Yeah. Yeah, if you look at the calendar, you'll see where we stopped last time. I don't have my calendar with me. I brought...
It stopped at the identities.
Pardon?
It stopped at the identities.
Identities? Yeah. So...
Yeah, it's good practice for the test.
Math gym.